Right, guys, we are done with lists. So now we are going to look at tuples. So tuples, these are just ordered collection of items, right? And these are read-only items, which means they are immutable, unlike lists. Once created, you cannot change them. We're going to look at examples, right? Let's write some code. Right. So the main difference with tuples is, let's say we have tuple 1. You can just call it, tuple 1. Let's call it tuple 1, right? Is equal to. Instead of using square brackets, you have to use round brackets, right? You have to use round brackets, right? And when I say they are immutable, it means you cannot change. Like when we were using lists, we had quite a number of functions, but as you can see, the only functions that we have are count and index, right? You don't have reverse, you don't have insert, you don't have append, you don't have all that, because this is immutable. You cannot change, right? So if you say, let's say you think you might get away with it and try to find some ways to increase the number of elements or to expand it, you see, it won't give you an error. But I want you to see what will happen if we print it. Let's see the contents, which means this tuple has been replaced by this one. This one has become the new tuple 1. That's why we say it's immutable. The purposes of this thing is for it becomes a read-only type of collection, right? So let's look at one or two things here. This is the same thing that we've been doing. Just to look at relook at the definition. A tuple is an ordered collection which cannot be modified once it has been created. So these are the keywords. Cannot be modified. You should always remember this, right? In other words, it's a special array, a read-only array. This is also special, right? And how to make tuples? These are defined in round brackets, unlike lists, which are defined in square brackets. You should always remember that. So let's look at this is an example of a mutability test. I think we've done this. For example, we have got this array. Let's just try to do it here. We can remove this. Let's just remove this and run this. We now have our new. If you want to check, we now have our new tuple, right? Let's say you want to replace 2, right? 2 is index 1. You want to replace it with let's say with 7, right? It will generate an error because it's simply immutable. This is a perfect demonstration that shows you that tuple read-only arichinjike. You see, this is the same. Object doesn't support assignment. A tuple yanyora data type and tuple object doesn't support item. If you still remember, if you want to discover the data type of a variable or whatever thing yanyora type, then within the brackets you write the name of the variable and it shows us this is a tuple. And we can do the same for lists. If we use type and go for an just in case. Just in case somebody out there doesn't know this. List. Right. We are done with this. So lists are mutable. We've seen this. We've done this example. For example, here you want to place a certain number, right? Which is 23, which is index 1. This is index 1, 23. You want to replace it with 45. It's easy. You can do it like this, and it. So it's okay to change just one element of a list, right? Operations on lists are slower, but they are more flexible. And since lists are mutable, they can be changed in place, in memory. There are many more operations we can perform on lists than tuples. And we can actually demonstrate this, right? that num list dot, you can see all these. We are not even going to count them. But if we if you want to discover the number of functions that we have for, you see, 2. You see, this is what they're trying to say, right? Mutability of lists also makes managing them in memory more complicated, right? So they aren't as fast as tuples. And you know, we have got your random access memory. Whenever you create a variable or a list, it creates a memory location, and a variable is simply a named memory location. Where is that memory? The memory is in the RAM, and we are looking at the random access memory. When the program is in execution, it creates memory locations for your variables, for your lists. So that makes it difficult for management. If kana immutable, because my changes they should be recorded in memory each and every time you make a change, right? So that reduces the speed of execution. It becomes slower, but they are more flexible, because if you can update, you can change, you can expand, you can do. It means lists are flexible to use. So these are just examples that we looked at this index and the value that you want to be placed in that index. For example, 012 I is going to be placed in index 2. We did this. Append, we did this. Extend, this is a new one. We saw it, but we didn't experiment with it. So it's the same as concatenation, right? For example, we have this list, and then you want to concatenate, you want to expand it, you want to extend it. 987. If you just write list dot extend, then the list that you want, you have to put it in square brackets inside the parentheses. We are not append, we're at the end. After A, we now have 987. So that's an example. You can go and experiment on your own. It's quite simple. We also have index. It returns the index of the element. For B, it is going to return 1. This is index 1. Then count B, it is going to count the number of occurrences of that element in that list. Then remove. You can experiment with this. Go and give yourself time to experiment. And that no spoon feeding. Yeah, that's your time to experiment. Feed yourself with a large spoon. Right? We looked at reverse. We looked at sort. Pretty much we did all of these things. I think we are done with tuples. Let's just look at these are some of the differences. The common characters. Both store arbitrary data objects. Both are sequence data types. A tuple doesn't allow modification. A tuple doesn't have methods. A number of methods. Count and index, right? The tuple doesn't support format strings. A tuple supports variable length parameter in function call. Tuples are slightly faster. Why are they faster? Because they don't have those complications. The mutability. And mutability comes with complications. So I think we're done with tuples here. We might want to look at Zasara about tuples in the textbook. So if you go to page 45, you do about tuples. But basically, textbook relations show. That's why we need to look for other material. Right. Tuples can be used for swapping numbers. And let's say you're asked to write a program to swap numbers. Then you can actually assign values. Let's say you've got a tuple which has got 2 values, 2 and 3. Okay, print 2 and 3. Right? You can assign. We've created new variables A and B, and these new variables are going to be assigned the values that are within this tuple. Let's write the code. Let's write the code. New tuple. This is our new tuple. Is equals to. Let's say we've got 4 and 8. Right? That's the tuple. Then you can actually assign values. Let's say we want to create variable A and B. We're going to create variables A and B. Then we are going to assign values. 4.8. Right? And then we want to print the value of A. The value of A becomes 4. The value of B, 8, right? B8. So you can either use that method, or you can replace this with the name of the name of the tuple. The name of the tuple, which is new t, right? New t, da, 4, da, 8, right? So this is another technique. It's now covered on a slide. Right, basically they're doing the same thing. Here they're just printing these things. So this is an example of a code to swap. What basically is happening here, the code is prompting the user to enter something. So per screen panel would enter the first number. Then let me describe this. First of all, I think I need to copy this so that you guys can actually see this in action. You want to see this running here. So let's just let's divide this. Let's divide this so that I explain one after the other in a chronological manner. Right. After I explain this user operations. Let's say you want to enter first number. The user is being prompted to enter first number. So if you want the user to enter something on the screen, you use input, right? Let's say we want to test case. That input. This is a function that accepts whatever keys that are going to be written on the keyboard by the user. It's going to this is going to be captured and saved and assigned to the test variable, such that Liverpool, the best team in the world. Liverpool, the best team in the world. Oh, sorry. Let's stop it from running. Let's stop it. Come on, stop. What's happening? Right. Yeah. That's Liverpool. So once you enter, for example, like this, you have to type Liverpool. Once you finish, press enter. Tab. Right. You're done. Then we want to print. What are the contents of the variable test? You see, test is a string. Liverpool. So whenever you see these single quotes or double quotes, it means the data type is a string. And it means the data type is a string. If you want to check, you use the same method that I shall survive by. Type, then test. It will tell you that this is a what? This is a string, right? So I just want to, right? You might want to change any processing on typecasting. Typecasting is the process of changing one data type to another data type. Right? For example, each time you type in input using the input function, and if you type anything from the keyboard, so this is our typer will come out as a what? As a string. Let me give you an example. Let's say you want to type numbers 1, 2, 3, 4. They won't be automatically converted to integers. It would still be a string of numbers like this. It's a string of numbers. Even if you test spanner, the data type is str, string, right? So if you want to convert the type, that's typecasting, you write the data type that you want to convert to. In this case, Tumura integer, int. Then whatever is going to be in there is going to be converted into this data type, right? This is what will happen. Number, let's say 3, right? So what this code is simply going to do is we're going to swap numbers. Variable num is got number 3. Let's say number 4, we're going to put it in variable num2 4, right? So once it's num4, once the variable is stored in num, the variable 4 is now stored in num2, right? The value 4 is now stored in variable num2. So the numbers entered we're printing the numbers that have been entered. These are the numbers that have been entered, 3 and 4, right? If you want to print something on the screen and combine